I don't know what the hell I'm like.
Cole and I worked on some videos. They're rough videos. We really didn't have time to edit everything, but they're not terrible. But you're just going to have to go through them. We tried to make them as enjoyable as possible, I think. With the email that was sent out, there was a evaluation form. If y'all could please fill that out, save it to your desktop, and then email it to Devin and tell us what you think of what we're doing, that would be fantastic. And if you have any additional ideas of what topics we may need to hit or you would like to see touched upon, we could use that as well. There was one additional thing attached to that, and I believe it's just some additional information that you could log on to learn, do some online training. I didn't really get a chance to check it out. I had yesterday off. I had a birthday thing yesterday. So I didn't get a chance to check it out, but you'll probably want to check it out. And that evaluation form is very important for us so we don't run out of topics too soon. Because, you know, there might be something out there that you want to hear about or may need refreshed. So that just benefits us. But today we're going to talk about some attic venting. We're going to try to do a 2-hour session. It may be done a little earlier. We try to time it out. Just bear with us. And there again, I'm still learning. So is everybody else. But let's get started on it. So attic venting. The purpose of attic ventilation, removes solar heat during hot weather and removes moisture vapor during cold weather. This is the way high and low venting typically in a perfect world will work. You got air coming up through your soffit vents. And right in here, I've got a better PowerPoint that shows this. There'd be some baffles in here. You don't want to fill this up with insulation. And just with the kind of like stack effect, the heat comes or the air comes in here, builds up heat, and it comes out through your ridge vent. Passive attic venting and convection, just like I said, hot air rises and escapes through the high vent, and it pulls the cooler air through the soffit vents right here. So as this air is heating up, it's venting out your ridge vent, and then it's drawing cool air in here. Heat rises and escapes through the ridge vent. I like this particular slide right here. We put it in. Right here's where your soffit vents would be. Right here's where your baffle is. I like this because a lot of the houses that you go into that has rolled in fiberglass insulation or even blown in insulation, sometimes it's clear up in here and it blocks this lower vent off, and it prevents the air from being able to flow up through here. So you're not really getting ventilation. Even though you may see soffit vents, if that's blocked off, there's no air being blown up through here. And it creates a negative pressure. I like this because it's got the shielding around the can lights. The only thing I don't like about it is it's completely covered. Sorry. Sorry, there's a dog in my yard. And the inside dog is not digging it at all.
Okay, I was going to say, Dave, it sounds like the dog is in your house.
Yeah, sorry, guys. Moxie, go lay down. But anyhow, the air comes up through your soffit vents there should be baffles in here. The insulation should actually run clear over top and cover the double top plate of the wall. And this should be your thermal and pressure boundary. And in the previous sessions that we've had, like the very first one of BWT, there should be no breaks in the thermal and pressure boundary all the way around to let any kind of air filter up into your attic. Ryan, when he worked for the training center, he always used the phrase, the only thing that your roof is actually doing on your house is keeping your insulation dry. And I like that because it's simple, but it's 100% true. And you need this ventilation to keep your substrate, what your shingles are. I don't know how many folks in here has ever tore off a shingled roof, but if you don't have proper ventilation in your attic, and your attic that has excessive heat, the shingles will actually melt onto your substrate, onto your plywood, and it is absolutely no fun to try to remove them shingles. They'll bake on there, and you'll probably be removing plywood with your shingles. So these baffles are needed. There's better illustration in a few slides ahead of us. And if you notice here, you got all the wall insulation coming up through here. This should be continuous all the way around the living space. And, you know, don't just take it for granted. I've built a lot of houses, and I've seen a lot of carpenters. They never use the formula for attic ventilation. I've never seen anybody use it. They'll just take a circular saw right up here on the ridge. They'll come down 2 inches and they'll rip that all the way down the ridge. But is that enough venting in your attic? They'll put this rolled ridge vent on here, and then this has got some sort of mesh inside there. And I just wonder how long.
Randolph,
it would take for like the stack effect to come in and plug all this up with the debris that is in the attic. And then, you know, there goes your attic ventilation. You need to know what kind of roof that you're dealing with. We got a gable roof. We got a gable roof with a dormer. This is what we have in the prop house. On the videos that we have to show you, we're using the prop house, and the prop house has a dormer on. Gable and hip valley. Gable with a shed roof on an addition. You'll see this a lot of times in your weatherization. A lot of the guys at the weatherization, they call them Goodyear houses because it was a good year and they decided to add on to it. So you get a lot of shed roofs. You need to know the roof design, what type of roof design that it is, to figure out what kind of you got a hip roof, hip and valley roof, low slopes, and a flat roof, shed or lean-to roof, gambrel roof, mansard roof, and a Dutch hip roof. All different kind of vent types. You got a mushroom vent. There's a video of me actually showing you folks how to install a vent on a shingled roof, an existing shingled roof. Say you guys are weatherizing the home and it needs more attic venting. We have a video that you folks are going to see here of me actually installing a vent, and it's a vent similar to this one right here. Well, you got a turbine vent, gable vent. I know when you guys was always there, me as a chip inspector, because there was one of these in the house, right up top or on the knee wall attic. These are your E vents. These will be where your soffit is. If you got a solid wooden soffit and you got to cut holes in it, you'd be putting something similar to this in there. And then this is a hat vent. That's what I call them, just a roof vent. One thing that if you are installing a roof vent on a house, you may want to put it on the back side of the house. You don't want to put it right up front where everybody driving down the road is going to be able to see that nasty vent. And you want it as high up on the roof as possible. Gable vents are attached similar to roof vents. You may actually have to get into some framing here. You'll want to put something across the top after you cut the siding and a framing member coming down on both sides, so you'll be able to nail your vent into it. And you want to back counter flash some of this with some J channel and such to make the water run off and doesn't get in behind and rot the substrate out. This right here, this just going up into the peak of the gable, basically the same thing. You may have to run something down and put some scat boards on the inside. You'll have to get creative because a lot of these gables have upright studs in them, just that goes down to the top plate on the wall. So you'll have to bust out some tools. In the video, I show all the tools that I used to install that vent. Post-weatherization attic moisture problems. This right here, the soffit vent is completely plugged up with cellulose or vermiculite, whatever that is. And it's not letting any air get to this. So you got mold on the underneath side of your sheathing. It's got moisture up in there and it has no place to dry out because there's no air coming up through here. Right in here is where that baffle would be. And that would keep your insulation from filling up your soffit area. These right here, I know I've seen it, go up in the attic in wintertime and there's a lot of moisture, and these are moisture frozen. That's water frozen on the end of them nail heads right there and on the bottom of that substrate. Probably won't take very long to rot that out. And the air quality up there cannot be very good. And this is what I was talking about, that eave chute. It's going to go right in here. And it's going to block that insulation being able to fill up that soffit area right there. And that'll allow airflow to come right up in between these two trusses and dry out all that substrate if there is any kind of moisture in it. Common misconceptions of attic ventilation. Attic ventilation always removes moisture vapor during cold weather. It doesn't always do that. Your attic actually should be pretty much the same temperature as it is outside if your thermal and pressure boundary is completely aligned all the way around the living space. Attic ventilation will cure any attic moisture problem. That's not true. You could have a roof leak. You got to fix that stuff first. The more attic ventilation, the better. There is a formula, rule of thumb formula. We're going to show it in a PowerPoint. And then we have video of Cole actually going through the procedure. And we measure the prop house. Attic ventilation is not necessary. Moisture flows with warm air through breaks in the air barrier and causing damage when it condenses in cool surfaces. So first off, if your thermal and pressure boundary isn't complete, you're going to have a problem even if you vent your attic. I threw this slide in there because I believe this is an important part of all of it. You need to have this continuous all the way around. That way you're not creating more of a problem of a heat loss coming in here. And when the heat goes up into your attic and your attic's cool, that creates moisture. And if you don't have any place for that moisture to go, it's going to fall right back down on your insulation and probably show up at the worst of times. Basements, conditioned or unconditioned. There again, I just threw this in here because I want to make sure that you folks understand that this has got to be aligned all the way around the living space with no breaks so it doesn't create more of a moisture and a heat problem escaping up into the attic. Knee wall or attic, the conditioned space. We threw this in here just for the terminology, crowned attic, finished knee wall, and to kind of show you, this has to be completely around the thermal and pressure boundary all the way, the whole way around, because this is a living space. We're going to, the next session that Cole and I is going to do, it's going to be about insulation. You're going to learn how to figure out how to do insulation on the walls and the attic. Typical units, surface area, volume, and airflow. That's what you're going to be talking about when we're talking about attics. Vent placement, you want vents as high on your roof as possible. I threw this slide in here because I think it's funny. There's probably not enough attic ventilation on this particular roof. And you notice all the snow all the way around, but you don't have any snow on the roof. So that's telling me there's some heat loss going up in, and it's melting that snow off the roof, because by all rights, there should be snow completely covered on that roof. That's another thing you can do in the wintertime, drive down through your neighborhood. If everything's all snow covered, the roof should actually be snow covered as well. If it's got a good thermal pressure boundary, if it's got good ventilation, because like I said, it should actually be the same temperature inside your attic as what it is outside. This is one of the venting formulas for an attic. This is high and low, I believe. The ratio of the attic, 1 square foot of net free vent area for every 300 square foot of floor area, if high and low is possible. And high would be like your gable vent or your ridge vent, and low venting would be your soffit venting. An example of this, 36 foot by 24 foot attic equals 864 square feet. You want to divide that by 300 for high and low. That comes out to 2.88 square feet of net free vent area. Well, you want to convert your square feet into square inches by multiplying your square feet, which would be 2.88. You want to multiply that by 144, because that's how many square inches are in a foot. And it comes out to 414.72 square inches. Well, at that point, we need to think about high and low venting. So you take that 414.72 and you divide it by 2. You want to cut that in half, because you want half of it up top and half of it down at the bottom. And it comes out to 207.36 square inches of high and 207.36 square inches of low venting. So what that's saying is you would have 207.36 square inches of ridge vent or gable vent, and then you would have the same amount in soffit vent. Now, if you cannot do low venting, say there's no way that you can cut in soffit vents in this particular house, and it could just simply be because of the type of roof that it is. As far as a gable, a HIF, or something like that. If you're only able to get high only, there is a different formula. You use 150 square foot ratio. And the example is they're using the exact same numbers what they did on the previous. A 36 by 24 attic equals 864 square feet. You want to divide that by that 150, which comes up to 5.76 square feet of net free vent area is required. That's in square feet, but then you need to change that back to square inches. So you want to multiply that 5.76 square feet by 144, which is how many inches are in a foot, a square foot, and it comes up to 829.44 square inches. And that's high only. That's probably going to come out to a bunch of hat vents. So you might want to think about some sort of gable vent or a ridge vent in there. You probably don't want to start putting 36 hat vents on a house. 1 foot of net free vent area, a vent needed for every 150 foot of attic. That's for high only. If vents are located high and low, it's 1 foot square vent needed for every 300 feet square of attic. And the example is 1,000-foot square attic with gable vents. 1,000-foot square divided by 300 equals 3.33 foot square vent needed. Two existing gable vents equals 12, or each 12 inch by 10 inch. So on and so forth. I threw this in here because you're going to need to know how to do square footage. 1 foot by 1 foot is 12 inches by 12 inches, and that's where we come up with the 144 inch squared, which is 1 foot squared. So 300 times 200 is 60,000 square inches. And to change that back into feet, you take 60,000 square inches and divide it by 144, and that equals 417 feet square. And when you're thinking about attic venting, you're using square footage. You're thinking of area, not volume. And here's a video that Cole and I put together. We tried to chuck it up just a little bit, so hopefully you enjoy it. And hopefully it works.
Good morning. I'm Dave. I'm here at the Ohio Weatherization Training Center. This particular session is about attic ventilation. We're going to do a rough overview of that as far as an inspection on our prop house that we have in the warehouse. This is a prop house that we do a whole lot of testing, different tests, blower door, pressure pan, connectivity test, the BPI test, but it's suitable for what we're going to do today. So today we're talking about attic venting. We're going to look around. When you first get out of your vehicle in the day, you want to try to get a good visual inspection of the house. You want to start at the top and work your way all the way down. Looks like we're dealing with a hip roof. You really need to know the roof type that you're dealing with. What type of shingles are on this particular roof. And this one here, it looks like we got 3-tab asphalt shingles. A little bit dusty from being in here at the warehouse, but other than that, that's what we're dealing with. A hip roof with 3-tab shingles. Doesn't look like we have any low venting, which low venting would be something such as soffit vents. This has nothing. This has solid 1x soffit on it, the vinyl siding running up to it. I don't see any kind of ridge vent on here, no hip vents. I do see a hat vent. Probably is not enough venting for this attic. So let's proceed on our walkthrough. On this particular side, you can definitely tell that it's a hip roof with asphalt shingles, and still no evidence of any low venting, no high venting as well. This particular house has a dormer. Is that an actual working dormer, or is it just there for beautification? It's a gable. It too looks like it has asphalt shingles. Is it vented? Is it part of the attic? Is it part of the living space? That's kind of what we're trying to determine here. We'll go inside, do a good walkthrough in there, and then we'll head up to the attic and see what we're dealing with for this particular home. And now we're going to get a look at the inside of the house, trying to see what could be the conditioned space and what may not necessarily be the conditioned space. So we're just going to do a quick walkthrough of the home. Again, trying to get a footprint of what the house looks like. Flip some lights on in here so we can see. From the looks at the insulation in the ceiling, this looks like the conditioned space. So quite possibly the whole upstairs in this particular house is the unconditioned space, which is probably the whole attic. The whole upstairs would possibly be the whole attic. And again, it looks like it could be a floored attic upstairs that has been dense packed. And it looks like we may have some ducts running in the unconditioned space upstairs in the attic. So let's go up into the attic and check it out and see what kind of condition we're dealing with. Okay, we're up here in the attic. This is the prop house for the Ohio Weatherization Training Center. So this is used for a lot of things. There's nothing telling me that anybody lives up here. So we're going to consider this the attic area. And it looks like it follows the footprint of the house, of the whole house. We got this area back in here. We do have somewhat of a knee wall situation. These are here for demonstration purposes, which we will be using later on in our videos to show you how to properly insulate a knee wall attic. But for this scenario, we're just going to consider that the whole upstairs in this house is the unconditioned attic space. And what we're going to do is we're going to measure the footprint of this place, the square footage from downstairs, since the upstairs mirrors the downstairs, and we're going to see how many net-free inches of air we need for venting to properly vent this attic. That's our goal for this segment. Hopefully you guys understand it, and hopefully we can convey it the right way. So let's go downstairs and measure and see how many square feet we're dealing with. Okay, we did a walk around on the exterior of the home. We did a walk around on the conditioned space of the home, and we did a visual walkthrough of the attic area of the home. So what I'm going to do, I'm going to draw the basic footprint of the house on a piece of paper that I have here.
He said, why work? You know, $800. Yeah, it's tax free. He's scared to leave the house.
So what I've done, I've just drew a basic footprint of the home because I know that the attic covers the whole conditioned space, so it's going to be the same. And when we're talking about attic ventilation, we're talking about square foot or square feet. We just need to know the area. A lot of attics are very difficult to access as far as standing up and being user-friendly as far as taking measurements. So the reason why I kind of drew the footprint of the home, I'm going to measure the square footage from the living space because the attic mirrors what we're standing in right now.
What you got there, Dave?
21 feet to the closet door. And I have an additional 30 inches, so it'd be 23 feet 6 inches. Grab my paper here. Feet 6 inches. Feet. The reason why I measured this room is the same width of this room. That particular wall originally goes all the way through. Now on this, I want to measure to this side of the wall because that's where I started my measurement for the width of this. So it's going to come up to 21 feet, 8 inches. And since that bathroom that is back there is included in this space, I'm simply going to measure from that wall to this wall, and I'll have the width of both of these rooms. If I can do that in a manner where I can read the tape measure. And I come up with 15 foot 6 inches. Okay, I now have all my measurements to figure out how many square feet my attic area will be.
All right, my name's Cole. We're going to figure out the area that Dave just measured in the prop house. First thing we're going to have to do is cut the prop house in two, because we got two areas. We got an L shape. So we're going to find this area, number one, and then we're going to add it to number two. So number one, we got 23 feet 6 inches by 11 feet. Now we're not going to have to, we can't measure the inches. We're going to have to cut that into a decimal point, and obviously that's 0.5. So we're going to go 23.5 times 11. 23.5 times 11, that's 258.5, 258.5 square feet. So to that we're going to add 15 feet 6 inches, which is going to be 15.5, times 21 feet 8 inches, which we're going to have to break that down. That's going to be 21.66666 feet. To make it easier on ourselves, we're going to say 21.7. Multiply those together, 15.5 and 21.7. 336.4 square feet. Now we're going to take the 258.5 and add to that 336.4. That's, I won't even use a calculator for. Carry the 1. And we've got 594.9 square feet. Now what we're going to do is we're going to make all this magically disappear, but we're going to maintain this number right here and figure out how much net-free venting area we have. And poof, and we're back. This has all magically appeared, and this is the formula we're going to use to find the net-free vent area. Net-free vent area. Is that correct, Dave?
That is correct.
So what we're going to do is we're going to take our area divided by 300, that's in square feet, and we're going to find the net free vent area in square feet. Well, we're not done, but wait, there's more. We're going to take the net vent free area in square feet, multiply it by 144, because you know what 144 is. Dave, you know what 144 is?
I think I know what it is.
What is it, Dave?
What is it?
It is 1 square foot broken into inches. So that's 144 inches.
Man, that's a whole lot of inches.
It is a lot of inches. You have no idea. And that's how we're going to find the net-free vent area in square inches. But you know what, Dave? There's more.
Is there more?
There's more. Wait, there's more. We're going to take that divided by 2 because we have to find the high and low in this.
Wait a minute. What is high and low?
Well, we're talking high and low vent areas. I'm glad you asked, Dave. So we've got to think, do we want just high? Do we want high and low? Where would a low vent area come from, Dave?
My first guess would be something like the soffit area, maybe.
Oh, boy, I heard bells. I don't know if they went off, but I think you're right.
I'm telling you.
Do we want to get in? Let's do the math first, and then we'll determine what we want to get into.
Right on.
Okay, so we're going to start with the 594.9, which is what we had as our area in square feet. First thing we do is we're going to divide it by 300 or 30 G's, either way. But I'm going to do that again, 300. So we're going to take, and we could guesstimate, I'm going to say this is just going to be 2.8 something. 294.9 divided by 300, 1983, 1983. That was way off. Of course we'll get under that. So we have 1.983. This is where we are in square feet, okay? Now we got to take that. What's the next thing we got to do? We got to take that and multiply it times 144. So let's bring this down here. 1.983 times 144. $285.6. So we have 285. Whoa, 85.6.
Looked like the marker kind of got out of hand here for a minute.
It's got like a mind of its own, an eraser mind of it. Now we are in square inches now, Dave, though. This is a nice thing about this, is this marker just went ahead and did this for us in square inches, where we got this. But we're not done. We're not done. We have to take this we have to take this 285.6. You know what we got to do? Slice that sucker right in half. 285.6 divided by Dos Equis. That is hang in there, I'm not done writing. There's a lot of marker use here. That is 142.8 square inches, both high and low. So if we're gonna put a high and a low vent in that prop house for the amount of square footage that we have in the attic, we're gonna need 142.8 square inches on the top as a top vent and at the bottom. But we might just want to not mess with the soffit like Dave was saying. So let's erase all this and we'll take a look at it if we're just doing the high vents. And we're back. here just 1 second after we left. I quickly changed my clothes. But we're gonna break this down. We're still looking at now just the high venting for the prop house. If you remember, our area was 594.9 square feet. And what we're gonna do is we're gonna take that and divide it by 150, and that's gonna give the square foot of our net-free vent area. Okay, that's part one. Part two, we're gonna take the square footage of the net-free vent area and multiply it times 144. Do you know why we multiply it times, Dave, do you know why we multiply it times 144?
I'm gonna guess to get the square inches.
So he's so inch friendly. Yes, because that's how you convert inches into a square foot. So back up here, area 594.9. I know that because it's written right there. We're going to take 150 into that. 5,949 divided by 150. 3.966, so we get 3.966. You can imagine I just did it all long way. It's the old school way right here. So now we're going to take this number, 3,966, because we've got it in square feet now, right? Now we have to convert it to inches, square inches. So we're going to multiply it times the 144, because that, again, the number of inches in a square foot. So now we've got that, 3.966 times 144. That's going to give us 571.1. There's other decimal points, but we're just going to go with that for right now. So that's 571.1 square inches of net-free vent area. And if you look over here on our nice little chart, we realize that for a 10-inch, where we put an 8-inch over there, an 8-inch vent is going to give us 50 and nearly a quarter inches of net-free vent area. So you can see, just with my semi-professional math skills, that's a lot of 8-inch vents on that roof. So it may be something that we better address with a ridge vent, or you're looking at putting about 11 more 8-inch vents.
All right, we're going to take a 15-minute break, and I'll see you folks back here at 11.